squared. Okay, I'm ready now. So explicit y equals. So to find the derivative of this function explicitly, we want to solve this for y. How do we solve this guy for y? Subtract 3x and then take the square root. Okay, so I'm going to solve this guy for y, subtract 3x. And then I'm going to take the square root. All right, how do you find the derivative of that? Yeah, chain rule, because square root is the same as 1/2, right? Square root is the same as 1/2. So this would look like 1/2, keep the inside the same, to what power? -1/2. So the inside is 5x cubed minus 3x times the derivative of the inside, 15x squared minus 3. Okay, so that is the derivative of that function explicitly. We had to solve for y and then take the derivative using whatever rules we have. It turns out we could find y prime. Remember, there's two notations for derivative. You could say y prime or you could say dy dx. I'm going to use this dy dx notation because it's really easy when you're writing y's and y primes together to get lost as to which one's which. So from whenever I do implicit, I use this dy dx so that I can keep that piece separately, okay? So implicit differentiation uses the chain rule. You pretend like everything is just normal and you're taking the derivative, but when you take the derivative of y, you say the derivative of y is dy dx. Okay, so use dy dx when you differentiate y. So here it says step 1, take the derivative normally. Each time a y is involved, include a dy dx. So what's the derivative of y squared? 2y, and then I'm going to put that dy dx there. I'm going to keep it in a different color right now, but eventually I won't do that anymore. Okay. Plus, what's the derivative of 3x? 3 equals derivative of 5x cubed? 15x squared. Okay, so I took the derivative normally. Anytime I take the derivative of something with a y in it, I put that dy dx at the end. Because the chain rule says the derivative of the inside, the derivative of the y part, is dy dx. Okay, step 2 says gather all the terms with dy dx on the left side and everything else on the right side. So what am I going to change here? Subtract 3. 2y dy dx is 15x squared minus 3. Step 3, factor out the dy dx if necessary to create only one dy dx term. We've got that already, right? We have dy dx times 2y is 15x squared minus 3. That's good. Okay, solve for dy dx. How do I solve for dy dx? Yeah, divide by all that stuff. Divide by that 2y. 15x squared minus 3 divided by 2y. Notice that in this case, your derivative has x's and y's in it, right? So when you use implicit differentiation, your derivative will have x's and y's in it. That's okay. If we wanted to, we could replace y by going back up there and solving it. But a lot of times we won't be able to solve for y. So we'll have to just leave our answer with x's and y's in it together. That's it. We're done. Yeah. Okay, so let's try again. We're going to try more where it gets a little bit more complicated. Okay, let's try this top left. Y cubed minus 2x equals x to the 4th plus 2y. What's different about this one than the last one we did?
There's 2y.
There's y in 2 different places, right? So when we take the derivative, we're going to get dy dx in 2 different places. So we'll have to do a little bit more work for that step number 2 that we didn't have to do before. Okay, to find the derivative, how do you start? 3y squared, good. dy dx, perfect. I'm gonna put that in pink again. Minus derivative of 2x, 2, good, equals 4x to the third plus 2. Anytime you take a derivative of something with a y in it, you put your dy dx there at the end. Okay, that was step number 1. Take the derivative normally, put a dy dx when you take the derivative of y. What did step number 2 say?
Oh,
Yeah, gather all the dy dx's on the left side and everything else on the right side. So I want this 2 dy dx to come to the left, and I want this negative 2 to go to the right, okay? How do I move the 2 dy dx to the left? Subtract it. And how do I move the negative 2 to the right? Add it. So the left side is going to look like 3y squared dy dx minus 2 dy dx equals 4x cubed plus 2. So this guy came over there, and this guy went over there. All righty. What did step number 3 say? Factor out a dy dx. Everybody on the left has a dy dx in it. Just factor him out into the front. So it looks like dy dx times, when I factor dy dx out of the first term, what am I left with? 3y squared, good, minus 2 equals 4x cubed plus 2. Yeah, I want dy dx all by itself. So I'm going to divide by all that stuff. It doesn't matter how much stuff is here, okay? You're just going to put all that stuff into the denominator. So all of that 3y squared minus 2 goes into the denominator. dy dx is 4x cubed plus 2 over 3y squared minus 2. Okay, let's try it again. 3x squared plus 4xy squared minus 5y cubed equals 10.
does the square just go to the one?
Does the
4xy squared? Or is it
4xy squared? Yeah, what do I have to use to take the derivative of 4xy squared? The product rule. Because I have 2 variables multiplied together. Anytime you have 2 variables multiplied together, you have to use the product rule. So for this middle term right here, when I'm taking the derivative, I'm going to need the product rule. Okay, derivative of 3x squared, 6x, plus my first function is going to be 4x, and my second function is going to be y squared. So the product rule says derivative of the first, so derivative of 4x, 4 times the second, y squared. How come I don't put a dy dx there? I didn't take the derivative of y, right? I only stick in a dy dx when I take the derivative of y. So right in that first term of the product rule, I was taking the derivative of the x. So I don't need a dy dx. In this second part, I'm going to need one. Okay, plus first 4x times the derivative of the second, derivative of y squared, 2y dy dx. Minus derivative of 5y cubed, 15y squared dy dx. Equals, derivative of 10 is 0, equals 0. Okay, step number 2 says put all the dy dx's on the left and all the other stuff on the right. So this 6x has to move to the right, and this 4y squared has to move to the right, but these guys already have dy dx and they're already in the left, so they're just gonna stay right there. So I'm gonna keep the 4x times 2y, 8xy, dy dx, minus 15y squared, dy dx, equals, when I move the 6x and the 4y squared to the right, what do they become? Negative 6x, good. Negative 4y squared. Okay, now what? Yeah, dy dx, factor it out because I want dy dx in my answer, right? So when I take dy dx out of the first term, I have 8xy minus 15y squared. I'm solving for dy dx, so divide by all that stuff. Oh, whatever's in there, it doesn't matter how much stuff is in there, just put it all in the denominator. It works the same way, whether we have trig functions or exponentials and logs. Implicit differentiation still works the same way. Okay, let's talk about this guy. Oh, sorry. Absolutely. More than that? That's okay. Okay, let's try this guy. Y times the sine of xy equals y squared plus 2. There's a lot of y's in that, right? I need the product rule. Yeah, I definitely need the product rule because I have y and I have a sine a whole bunch of stuff, right? But inside the sine, I need the product rule again, yeah? Because I have that xy inside the sine. So I'm gonna need like the product rule, the chain rule, and the product rule. This left-hand side is gonna look like total nonsense, right? Because I'm gonna need the product rule, the chain rule, and the product rule again. Okay, I think what we should do is take the derivative of sine xy over on the side. Like, let's make a note over on the side to find the derivative of sine xy. Okay, so if this is my function g sine xy, what's its derivative going to look like? Derivative of sine is cosine, leave the inside alone, times the derivative of the inside. So on the inside, I have x times y. The product rule says derivative of x, 1 times y, plus x times the derivative of y. Yeah, 1 dy dx. So when I'm taking the derivative of this left-hand side and I have y and sine of xy, when I need the derivative of sine xy, I'm going to put that whole thing in. Okay, so I need the product rule again, right? Y is my first function, sine of xy is my second function. The derivative of y is dy dx sine xy plus y times the derivative of sine xy. That's this big thing that I just found right here. Cosine of xy times y plus x dy dx equals derivative of y squared, 2y dy dx plus 0. Derivative of 2 is 0. Okay, look how many dy dx's are. There's one here, there's one here, and there's one here, right? In order to get to this one inside these brackets and parentheses, I need to do some like major distributing. Yeah, this is y times cosine xy times y, and y times cosine xy times this thing. So before I can do the put the dy dx's on the left and the other stuff on the right, I need to distribute this so that this dy dx can get out, right? Like right now he's kind of stuck inside there. So the first term is dy dx, whoops, dy dx sine xy plus, I'm going to distribute this y and this cosine to both pieces. The y and the cosine are going to get distributed to both pieces. So I have y squared cosine xy plus xy cosine xy dy dx equals 2y dy dx. So I did y times this guy, and then I distribute it to both of those pieces out there. Okay, now I need everybody with a dy dx on the left side. So this one, and this one on the left side, and everybody else, namely this guy, y squared cosine xy, on the right side. So the only thing I have to do is move this 2y dy dx to the left and move this y squared cosine xy to the right. So dy dx sine xy plus xy cosine xy dy dx minus 2y dy dx equals, when I move this guy to the right, he gets a minus as well, y squared cosine xy. Okay, now what? Factor out the dy dx. Yeah, I gotta write down a whole bunch of stuff again. When I take dy dx out of the first term, I'm left with sine of xy. When I take dy dx out of the second term, I have xy cosine of xy. When I take dy dx out of the third term, I'm left with negative 2y is negative y squared cosine xy. Okay, last step, divide by all that stuff. So we have a really big denominator. Sine xy plus xy cosine xy minus 2y. Right? We're doing some calculus now. There's like this point in the semester where things get like to their hardest, like we're at like, you know, maximums, and then we kind of go downhill after that. But we got 3 good weeks of being up here. 1 before the midterm and 2 after. Down. At least it ends on a good note, I guess. That's going to be good to enter in infinity, don't you think? Make sure when you're entering things in infinity, you're putting parentheses around your arguments of sine and cosine. Like if you have more than one thing inside your sine and cosine, it wants parentheses in there. All right, here we go. Find the equation of any tangent line for x squared plus y squared equals 4 at x equals 1. Find the equation of any tangent line for x squared plus y squared equals 4 at x equals 1. Okay, this is tricky because it doesn't say the tangent line, right? It says any tangent line. So what does that make you think? There might be more than one, right? There might be more than one tangent line at x equals 1. I want to graph this function. So let's get out Desmos and see if we can graph this function. X squared plus y squared equals 4. Okay, here's x equals 1. Let's draw it. X equals 1. Here's x equals 1. Here's one point where this function touches x equals 1, right? Here's another point where this function touches x equals 1. I could find one tangent line up here or another tangent line down there, right? Do you see that these two tangent lines have two different slopes? Yeah, one has a positive slope and one has a negative slope. So there are two possible tangent lines when x equals 1. If they only wanted this top tangent line, they'd have to give you more information. They'd have to tell you which y value to use. If they only want this bottom tangent line, again, they're going to have to give you more information. They have to tell you which y value to use. At this point, either of these tangent lines are going to work. Okay, so if x is 1, can you tell me what y is? How would you find y if x was 1? Plug it in. 1 squared plus y squared is 4. Y squared is 3. So y is plus or minus square root of 3. So there are 2 points, 1 comma the square root of 3. That was the point at the top of the circle. And then 1 comma negative square root 3. That was the point at the bottom of the circle. That means that there are 2 tangent lines. This one here at the top that has a negative slope, and this one here at the bottom that has a positive slope. Let's just go with this one where it's 1 comma square root 3. Okay, we're going to just use the tangent line at that point, 1 comma square root of 3. If we want to, we could use the tangent line at 1 comma negative square root 3, but we're just making a decision that said found anyone, so we're going to use that one. Okay, how do you find the slope of the tangent line? You find the derivative at your point, right? So we're going to find the derivative of this function. How are you going to find the derivative of that function? Implicitly, yeah. I mean, now that we know it, we may as well use it, right? Okay, what's the derivative of x squared? 2x plus, what's the derivative of y squared? 2y dy dx equals 0. Derivative of 4 is 0. Okay, I don't need to find dy dx as a formula, right? Like I'm just looking for the slope at that particular point. So if you want to, you could solve for dy dx. But you could also just take your point, 1 comma square root 3, plug it in for x and y and get your number for your slope. Doesn't matter. Let's solve for dy dx, just so that if we wanted to, we could find the other tangent line. So I subtracted 2x to put it on the right. Then I divide by 2y is negative x over y. Okay, so my slope is going to be negative 1 over square root 3 because my x was 1 and my y was square root 3. When oh yeah, I didn't do plus or minus when I took the square root. I mean, how would we define the derivative with plus or minus? We would have 2 derivatives. Yeah, yeah, see, it's really tricky. Yeah. We were just assuming positive at that point. Yeah.
Has to be plus or minus.
We know this because we're solving for a number. Yeah, so what he's talking about is when we, at the very beginning, when I solved for the equation explicitly and I took a square root and I just declared it to be the positive one. But here we said we could do this tangent line at the top where it's +3 or positive square root 3, or this tangent line at the bottom where it's negative square root 3. And we're just deciding that we're going to use a positive one. But we could have very well given an answer with the negative one because they said n.
What was the other equation? The slope would be 1 over negative square. Oh, negative 1.
It would be positive because it would be -1 over negative square root 3. Yeah, so it would be positive. Okay, so let's find the equation of the line. This is my slope. My point was 1 comma square root 3. Equation of a line is y minus y1 equals m times x minus x1. So if I put this guy into decimals, this y minus square root 3 is -1 over square root 3 times x minus 1. It should touch that circle at the point 1 comma square root 3 and go in the same direction. Yeah, it should draw me this pink line at the top. So I'm going to try that. I'm going to put that in Desmos, see what happens. I don't mind the square root in the denominator. It's okay for the square root to be in the denominator. I'm going to turn this guy off so that we don't get confused. So there's my point, 1 comma square root 3. There's my curve, x squared plus y squared equals 4. And there's one of my tangent lines. Yeah, there was another one at the bottom, which we didn't find. We could have, but there's one of my tangent lines. Looks like a pretty nice tangent line, right? Okay, given that 4g of x plus x sine of g of x equals 72x squared minus 73x plus 8, and g of 8 over 9 is 0, find g prime of 8 over 9. Wow. I need to find g prime of something, right? G prime of something. What do you think I should do to this function to find g prime of something? I want g prime. What do you think I should do to this function? Do you think I should try to solve for g? Solving for g would be really hard, right? Like, because g is here and it's inside the sign. So trying to solve for g before I take the derivative would be really hard, yeah? But I do know that I want to find the derivative. How come I know I want to find the derivative? It says g prime, right? So what kind of differentiation should I use since it's too hard for me to solve for g? Implicit, yeah? You can kind of think of g as being your y, right? Like you could pretend that this says y of 8 over 9 is 0 and y prime of 8 over 9 is what you want to find, or dy dx is what you want to find. You could pretend that g is your y. So anytime you take the derivative of g, you're going to stick in a g prime because that's what the chain rule says to do, right? So you did anything beside the chain rule for this function? A product. How come? Yeah, because you have x times sine of g of x. Anytime you have two variables multiplied together, you need the product rule, right? When they're just stuck one inside each other, you just get to use the chain. Anytime you have two variables multiplied together, you need the product rule. Okay, derivative of 4g of x is 4 g prime of x. Good. Plus, I need the product rule for this guy. My first function is x. My second function is sine of something. Derivative of x is 1. Sine of g of x plus x times. Derivative of sine of something is cosine of something times, yeah, dy dx or g prime of x equals Yeah, 72 times 2, 144x minus 73 plus 0.
You didn't put dy dx to g prime.
Yeah, instead of writing dy dx's, I wrote g primes, but you can think of them as the same thing. Like these are my dy dx's. So what should I do now? Yeah, we want g primes on the left side and everybody else on the right. It turns out at this step, when they're just asking you for numbers, you can plug in numbers, right? If you're more comfortable manipulating numbers, plug in numbers. Just be careful not to combine things that are not like terms, right? Like if somebody's got a g prime and somebody else doesn't, you can't squish those two numbers together. That will cause you problems. So if you feel like you're going to make those number errors, solve for g prime first. If you feel like you're good at manipulating numbers, go ahead and put in the numbers first, okay? The previous one we did, we solved for it and then we put in the numbers. This one we'll try putting in numbers and then solving and see how we go. We're going to plug in 8/9 for all the x's. That's what I'm going to do. I'm plugging 8/9 for all the x's. Because it says g prime of 8/9. So everywhere I see an x, I'm replacing it with an 8/9. This guy here says, oh my God. 8/9. So all of these x's, every single one of them turns into an 8/9. Okay, now I'm going to do numbers. I don't know g prime of 8/9, so I'm just going to leave him as g prime of 8/9. G of 8/9, that was this value that they told me right here. G of 8/9 is 0. So this guy's going to be a 0, and this guy's going to be a 0. So sine of 0 plus 8/9 cosine of 0 times g prime of 8/9 equals. This side is only numbers, right? There's no g's there. So put that number in your calculator and see what you get. 144 times 8/9 minus 73 is what? 128 minus 73. 55. If you put this whole right-hand side in your calculator, there's no g's on that right-hand side at all, right? So that's only numbers. Okay, let's evaluate these guys. What's the sine of 0? What's the sine of 0? Sine of 0 is 0. What's the cosine of 0? 1. Cosine of 0 is 1. Okay, so the left-hand side looks like 4 g prime of 8/9. This middle term, sine of 0 is 0, so he's gone. Plus 8/9 g prime of 8/9 equals 55. Are these two terms alike? Would you call these like terms? Can you combine them together? Yeah, because they both have exactly the same thing, right? G prime of 8/9. So we have 4 g primes plus 8/9 g primes. So to calculate how many I have total, I'm going to do 4 plus 8/9. That's going to tell me how many g primes I have. So 4 plus 8/9 makes 44/9. G primes of 8/9 equals 55. I'm trying to get to g prime of 8/9. Multiply by 9/44? Sure. Or divide by 44/9, whichever you like better. G prime of 8/9 equals 45/4, let's say.
So can sine 0 also be pi of?
No, that's the inverse sign. Could be pi, right? If you're finding an angle, yeah, but if you know the angle, because 0 is the angle in this case.
Okay.
So you know the angle, you're just spitting out the sign, so the y value on that place is unit circle. Is that the end? You guys know what the end? Oh, that is the end. I don't know if I got 45 over 4 right. Did anybody check it?
Just 9/44.
This
Not
was
44 over 9?
This was 9/44, because you have to do the opposite of what's over here.
Okay.
If you're multiplying. Multiply by the reciprocal. Okay, today's quiz day, 2 quizzes, D2L quiz number 5, grade school quiz number 4. You have homework due this week. We're doing 2 more things this week. We're learning some more new rules on Wednesday. So if you have that rule sheet, take that out. If anybody wants another cupcake, take a cupcake anyway out, or if you didn't take one, you can take it. Okay, guys, see you Wednesday.